In the previous chapter, we demonstrated how to be more precise and flexible with constraints by using rich versions. In this chapter, we will highlight an important scenario that can arise with resolvable configurations and how to address it. In our calculator application, if we add a runtime-only dependency on logging interceptor version 5.3.2, it makes our runtime class path and compile class path diverge. When we run the dependencies task, we see that the version of OKHTTP in the compile class path is 5.3.0, but the version is 5.3.2 in the runtime class path. By default, Gradle resolves dependencies for each configuration independently. This can lead to inconsistent versions of the same library in resolvable configurations. In this example, the runtime class path will use a different version of OKHTTP than the one used during compilation. This can lead to subtle, hard-to-debug issues. We want the same version of OKHTTP to be used in both class paths to avoid bugs. To fix this, we could manually add constraints that enforce the same version. However, there are times when you cannot manually add constraints. For this, Gradle provides a convenient method to enforce library version consistency across all configurations called consistent resolution. When you enable consistent resolution, you tell Gradle to treat one configuration as the source of truth. You typically configure this in your build file in the Java block by adding the consistent resolution block. Gradle then ensures that every other resolvable configuration is forced to use the exact same versions of all shared libraries. In here, you can configure whether the compile class path or the runtime class path is the source of truth. In this example, we will make the runtime class path the source of truth. Now, when we run the dependencies task, we can see the runtime class path is the same. And for the compile class path, Gradle created a constraint for each library version in the runtime class path. And used that to enforce the same versions were used in the compile class path. Note that this only affects projects on which the consistent resolution configuration has been applied. It does not carry over to other projects where the configuration has not been applied. By using consistent resolution, you can prevent subtle bugs and maintain uniformity in your project's dependency versions across different class paths.
If you had a large project and wanted to check if a dependency was resolved to the same version in all the subprojects, doing so with the command line dependencies task can be very tedious. You'd have to run the dependencies task on all the subprojects and look through the output. Instead, when you run a build on the project, you can pass the --scan flag, which will create a build scan. Here is a scan from the Android X project. If we click on the dependencies, you can see there are a lot of subprojects. Let's say we wanted to check if the same version of Commons IO was being used across the board. In the search box, we can enter Commons IO and see different versions were resolved for it in different subprojects. With this information from the build scan, we can follow up to see if this is acceptable or needs correction. You can also filter by projects or configurations. Build scans are very useful when searching for dependency insights for large projects.